Hello guys, I'm back with another video today. Today I'm going to discuss about Kohlrausch law and how to do numericals in Kohlrausch law within a minute time in an exam like NEET or JEE. So let's begin with the concept of Kohlrausch law. Let me just introduce you to what Kohlrausch law is first. So let's get started with it. So Kohlrausch law basically means that, let me just give you a rough idea, then I'll go to the statement part of it, right? So suppose you have a strong electrolyte like NaCl or maybe KCl, or you have a weak electrolyte like CH3CONA. Kohlrausch law says that if I add enough amount of it, meaning I made it 100% diluted, we can say it is infinite dilution. I've done it infinite dilution, meaning we have added as much of water as possible to make it infinite dilution. So the law says that at infinite dilution, it will break 100% into ions. Okay, and this word in this we put infinity sign, just saying that this is the infinite dilution. Basically infinity implies that. So for a substance like a salt like ACl, the molar conductance at infinite dilution will be the summation of the conductance value of their individual ions, which is lambda m infinity of K plus and lambda m infinity for Cl minus. So for strong electrolyte it's already broken, we know that, but this is true also for weak electrolyte. This is what it says. So even for weak electrolyte, it's going to be summation of infinite dilution of acetate ion plus lambda infinity for H plus ions. Yes, of course. So this M implies molar conductivity. It's fine. We can add an M here also. So this is what Kohlrausch law tell us about. So let's see the statement now. Kohlrausch says that limiting or molar conductivity at infinite dilution. Limiting means the same thing here. The limiting molar conductivity of an electrolyte can be expressed as the sum of individual contribution of the anion and cation of the electrolyte at limiting molar concentration. Like for example, they've given another example of NaCl. See, something that I already explained to you. So basically, it says that if you have a solution in which whether it is a strong electrolyte or a weak electrolyte, if you are adding enough of water so that it becomes highly diluted, then it will break 100% to ions, whether it is a weak electrolyte or a strong electrolyte. And the conductivity value would be the summation of their individual ions. Like in case of KCl, it is K plus and Cl minus. In acetate ion, I know it's acetic acid, I know it's a weak electrolyte, right? Despite that, it would be the summation of their own ions. That's it. Let's move further and understand the deep of the other part. Let's do with a quick question. So here we have it. So please pause the video, take 30 seconds time and do it. So pause the video. Okay, so let's be back and let's solve this question. So what is CaCl2 made up of? It's made up of Ca2 plus and 2Cl minus. You have to notice that part. Yeah, it has to be 2Cl minus, right? It's 2Cl minus. Therefore, it would be the lambda m infinity for CaCl2 will be lambda m infinity for calcium 2 plus ion plus 2 times. Okay, don't do that mistake of not putting 2 there, right? So it would be 2 times the chloride ion. Now, see the value here would be, yeah, of course, just put the value and get the answer. Simple. So lambda of calcium is 119. So put it like this, 119 plus 2 times the chloride value, which is 76.3. 76.3. And you shall get the answer. So I hope you got the idea, right? So let's see the solution of that. See. Simple, we had broken into ions. We did the level 156.26 and answer is 271.6, which is option number 2. Exactly. I hope that you got the same answer. The correct answer is option number 2. 271.6 Simon centimeter square mole inverse. So let's go to the next one now, shall we? So let's go. Next concept that we have to answer is with a quick question, just for a conceptual clarity. Let's do another question. So you may pause the video and do this question. Okay, so solve it. Okay, let's do this. See the solution now. To solve this question, what you have to do is you have to first ionize the salt. A2B3 will break into ions to form 2A plus, mind it, and 3B minus. So the lambda m value infinity for a to b3 would be 2 times the lambda infinity for a plus 3 times lambda infinity for b minus, right? And then after that, you just have to put the values. But since it doesn't ask that, we just have to choose the correct option. So will you tell me what's the right answer? Obviously, the answer is going to be, of course, the charges you have to write. So it will be C, A2, B3. See why I'm writing like that? Because see, it's a crisscross method. The charge here would be A2 plus, as you can see, and B. See, here it's what? Aluminum is 3, A is 3, so it would be A3 plus, and it would be 2B minus, B2 minus. So we'll write like this, A 3 plus, because see, that's how we got it, right? Crisscross. Like for example, Al2 is 3. How we got this? Because we had aluminum 3 and sulfur 2, which cross multiplied to give me the answer, right? So it would be aluminum 3 plus sulfur 2 minus. Similarly, here also it will be aluminum A3 plus and B2 minus. So this is the exact answer. So let's match it up. Is it A? No. B? No. C? No. Could it be? No, not really, because it not doesn't match. The answer is D. So the right answer is D. So I hope you got it. So let's get start. Go to the next one and go to the next part of the question. So the answer is indeed D. So let's continue with the next one. So this is the one for which we have made this video. This kind of question is time consuming, right? So if you see the real standard approach, it is like this. First, we have to break the ions. Okay, so why don't you like pause the video and then do it, and then I shall discuss the answer in the after a minute or so. So take a minute time, do this question. Okay, I hope you paused the video and done the question. Let me now tell you the standard approach. What you typically do when you do it in school. So lambda infinity would be for NaCl will be what? It will be lambda infinity for Na plus lambda infinity for Cl minus. And this is your desired value. So we'll first write this also because this is your target. Okay, like we take it as a target one. So I want to get this somehow, and the C plus and lambda m A minus AC minus. I want this. This is my aim. So using these three data set, I need to somehow get that aim. This is what we do. This is how we approach. So I've written this equation. I'm calling it as equation number 1. And that is a value of 126.5. So I'll write it 126.4. Very well. Next one, lambda infinity for HCl. And we shall write it like this. Lambda infinity for H plus lambda infinity for Cl minus. Infinity for Cl minus. That's equation number 2. Then we have the third one, lambda infinity for NaAC and lambda infinity for Na plus and lambda infinity for Cl minus. This is the exercise we do. That's a lot of work, right? Now we think of like what are the possibilities that we may consider to get the equation number, this aimed equation that we have, right? So I want H plus and I want AC minus. The rest all I want to get cancelled, right? I want them to be cancelled. So how should we proceed with this? So see, the way would be, the ideal way to approach this would be getting rid of Na plus somehow, right? And how is that possible? That is possible only when we subtract equation 3 with 1. See, if you do that, this is 3 minus 1. So lambda infinity Na plus will go, because see, I'll do it like this, lambda infinity plus lambda m Cl minus. So Na plus will go. So I'm still having this AC. I'm having this AC, but I have this extra chloride also. So for that, we will add it with this guy, and that's done. That means it has to be 3 minus 1 plus 2. Then all this will ultimately get the answer. So this is the standard approach, but this is not something that I recommend you do in the exams where it is speed based. So I'll tell you a simple technique. See, the technique is very simple. This one is easy one, yeah. You can do it like in any method whatsoever, but for complicated question, this method will definitely work. So what we do is, using these four, make any random equation. Using these four chemicals, make any random equation. It doesn't have to make sense. It can be any random equation. Okay, like I'm just writing this one. HAC will give me any random equation. The only trick is it has to be balanced. That's it. So I'm just writing a random equation. NHC plus HAC will give me, make an equal to sign, will give me HCl plus ACNA, right? See, NaAC. So I did that, right? And after this, you have to balance it. Sodium 1, sodium 1, it's balanced now. Put the values. 126. I'll just do the rough one. 126. This is 425. HCl is 425. HAC, I don't know. X. NaAC is how much? 91. That's it. Equate them. Meaning 126 plus X is equals to 425 plus 91. Done. Finished. See, X will be 425 plus 91. How much is that? 425 plus 91 is, see, 6, right? And this will be 516. So it would be 516 minus 126. So 516 minus 126, which is going to be 390. So 390 approximately. So the answer is option 1. It hardly takes a minute, not even that, lesser than that, and we can get the answer correct. So I hope you got the idea behind doing the questions of Kohlrausch law. This is the standard way, and this is the best way you can do the question. You may practice some more questions. Just keep in mind that you make an equation, it doesn't have to make sense, but it has to be balanced. Put the data, get the answer. So I hope you understood the point, and I'll give you few more questions, and then we shall wind up with this video. So let's do some more questions.